Hello, I'm Mrs. Neill, and this is lesson number 6, Biconditional Statements. Our vocabulary for today is biconditional statement, and then the term P, if and only if Q. We're going to learn what the term if and only if is in a biconditional statement today. So let's go back and review for just a little while. A conditional statement is a statement that can be written in the form if P then Q. And we can also write it P arrow Q, which means the same if P then Q. That means P is our hypothesis and Q is the conclusion. For an example, if an angle is a right angle, then its measure is 90 degrees. Meaning that an angle is a right angle, that's my hypothesis, and its measure is 90 degrees, that's the conclusion. So that's what a conditional statement is. Now, let's look at a converse statement. This is a review also. The converse of a conditional statement is formed by exchanging the hypothesis and the conclusion. So it's going to be if Q, then P. So it's going to read P, then Q, or Q, then P. So right now our hypothesis is an angle is a right angle. That's going to switch down here, and that's going to become the conclusion. And its measure is 90 degrees. It's going to switch over this way. So the converse of a conditional statement is basically what you're doing is just flipping it. But you still want to say if is your first word. If an angle has a measure of 90 degrees, then it is a right angle. When you write and when you speak in these terms, it has to make sense. You don't want to say, if measure of 90, then right. You want to make sure it's a nice, complete statement that makes sense. So now that we've gotten down the conditional statement and its converse, let's go to the third one, which is called the biconditional statement. A biconditional statement, remember bi means two. It's when you combine a conditional statement and its converse. Then you create a biconditional statement. Its form, this can be written in the form P, if you notice the double arrow, Q, which says P if and only if Q. And this means if P then Q, then if Q then P. So if you see this double arrow right here, that means that is a biconditional statement, and then you're going to use the term if and only if in your sentence. So let's now look at an example of a biconditional statement. Let's start with a conditional statement. If an angle is a right angle, then its measure is 90. Now let's look at its converse of this conditional. If an angle has a measure of 90, then it is a right angle. Those are both true statements, aren't they? So now let's write this conditional and its converse as a biconditional. And we're going to have the wording if and only if in there. Okay? So now here is our biconditional statement. An angle is a right angle if and only if its measure is 90. Notice when we write a biconditional, we don't have the if and the then part. See, we have an if here and then a then there. What you do is you start just writing your statement out. An angle is a right angle. That looks like that's a hypothesis. Then you write if and only if. In the middle, its measure is 90, and that looks like the conclusion right there. That is a biconditional statement. So now, if you notice, this was true and this was true, and so as a result, it makes the biconditional statement true. Let's look at an example that cannot be a biconditional. Okay, one example is a conditional statement is, if I live in Texas, then I live in the United States. What is the converse of that statement right here? If I live in the United States, then I live in Texas. Now let's go back and let's do a truth value. Is this statement right here true? Is the conditional statement true? If I live in Texas, then I live in the United States. Yes, that is true. But let's look at its converse statement. If I live in the United States, then I live in Texas. Is that true? No. You could live in New York, California, Hawaii. There's many places you could live and not have to live in Texas. So I cannot make this a biconditional statement because even though this is true, the converse is not true. So remember, the conditional and its converse both have to be true in order to write a biconditional statement. Okay, let's look at another example. Here's one. Here's our conditional statement right here. If two angles have the same measure, then the angles are congruent. Okay, if two angles have the same measure, then they are congruent. That is true. Let's take the converse of that statement. If two angles are congruent, then they have the same measure. That is true also. So can I write that as a biconditional statement? Yes, I can. So when I both write it as a biconditional, I go back up to my conditional, I take off the if and the then, and I put if and only if in the middle of it. Okay, so let's see what that's going to look like. Since both the conditional and its converse are true, you can combine them in a biconditional statement using if and only if. So let's look at our biconditional. Two angles have the same measure if and only if the angles are congruent. Notice you have your if and only if right in the middle. And that tells me right there that that is a biconditional statement right there. Okay, now we're going to work backwards now. I'm going to give you a biconditional statement and you are going to give me its conditional and its converse. So this is the last thing we're going to do. Here we go. Write the conditional statement and its converse statement within the following biconditional. Okay, this is a biconditional statement. An angle is a straight angle if and only if its measure is 180. See the if and only if? That tells me I know it's a biconditional. Now I want you to take that and write a conditional statement and its converse. So I'm going to take this first part as my hypothesis. Then I'm going to take this last part as my conclusion. Now remember, if you do a conditional statement, it's if P, then Q. So let's look at what that would be written as. Okay, so if, here's my hypothesis, an angle is a straight angle, then its measure is 180. There's my hypothesis there. Okay, now I want to write the converse of that, of this biconditional. So I'm going to look right here at my conditional statement. Remember, this is if P, then Q. And what I do is I just flip it. If Q, then P. So my converse will be, if the measure of an angle is 180, then it is a straight angle. That is our lesson for today. I'm Mrs. Neill. Thank you for listening.